Day 612 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1975, maximum matrix sum. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n integer matrix. You can do the following operation any number of times. Choose any two adjacent elements of matrix and multiply each of them by -1. Two elements are considered adjacent if and only if they share a border. Your goal is to maximize the summation of the matrix's elements. Return the maximum sum of the matrix's elements using the operation mentioned above. Okay, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input matrix is equals a 2D grid, or a 2D array. First array being 1, -1, next array being -1 and 1. So first, I just want to point out that each one of these arrays represents a different row, right? So this array right here represents the top row, and this array right here represents the bottom row of this boom. The output is 4. So that means we were able to maximize the sum of this entire n by n grid so that the output, or excuse me, that the sum of all of these elements ends up 4 by doing this operation right here, right? So let's go through it. It says the explanation, we can follow the following steps to reach sum equals 4. So first we're going to multiply the two elements in the first row by -1. So remember, we have this operation to do right here, and we have to use this operation in this grid so that we can maximize the sum of all of the elements in this grid. So the first thing we're going to do is, when we do this operation, both of the squares need to be adjacent to each other, meaning that they share a border. Boom. So first we're going to apply the operation to these two elements, 1 and -1. So that's going to turn this into -1 and this into 1. Boom. So now we have a 1 over here and a 1 over here, and we have a -1 over here and a -1 over here. Then it says multiply elements in the first column by -1. So that's what we are going to do right here. This is the first column. You know, a negative times a negative is going to equal a positive. So once we multiply both of these by -1, now every square in the box is a positive and it's equal to 1. And when we add all of these squares together, there's 4 squares with 1 inside, with a value of 1 each. So the output is 4. Now, I hope that made sense to y'all, but just in case it didn't, let's take a look at example 2. In example 2, same principles apply. So in example 2, this time our input matrix equals a 2D array. First array 1, 2, 3. Next array -1, -2, -3. And then the last array is 1, 2, 3. Once again, these each represent the row. So this would be the top row. Boom. This would be the middle row. Boom. And this would be the bottom row. Boom. The output was 16. Explanation says we can follow the following steps to reach the sum equals to 15. We're going to multiply the last two elements in the second row by -1. So that's these right here. So as you can see, everything up here is already positive, and everything down here is already positive, but this row is all negative, right? But once again, a negative times a negative equals a positive, so we're just going to multiply each one of these by -1, and that's going to turn this into a +2. That's going to turn this into a +3. And then when we add up all of these together, our sum will be 16. Sorry, when we add up all of these together on this side, the sum will be 16 after we turn these two squares positive. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we are going to do is we're going to declare a variable. We're going to open up the parentheses. We're going to say abs sum. So ab sum. Sorry, y'all, sum. And that's going to be the sum of the absolute values of all the numbers in the matrix. Then we're going to say comma. We're going to say min abs. Sorry, y'all, I should say abs. And min abs is going to be the smallest absolute value in the matrix. And then we're going to say comma, one more. We're going to say odd neg. Boom. An odd neg is a flag to check if there's an odd number or negative numbers. So for that, we can, or excuse me, then after that, we can come right here and we can open up the parentheses and we're going to initialize it by saying 0, comma, int dot max, comma, 0. Sorry, this will be 0. Boom. Now we need to iterate through each row in the matrix. So we're going to come underneath this. We're going to say for row in matrix. Boom. Then we're going to open up the brackets and we're going to say for. We need to iterate through each number in the row. So we're going to say for num in row. We're going to open up the brackets. And then we're going to add the absolute value of the number to the total sum. So we're going to say abs sum plus equals, excuse me, y'all, abs, open up the parentheses, num. Boom. Now we need to keep track of the smallest absolute value. So we'll come underneath this and we'll say min abs, and we'll set that equal to min, open up the parentheses, min abs, comma, abs, open up the parentheses, passing num, and this is going to return whichever one is smaller, min abs or the absolute value of num. Boom. Now, if the number is negative, we need to toggle the odd neg flag, and we're going to use the XOR, bitwise XOR operator, and flip between 0 and 1 for each negative number. So we're just going to come right here, and we're going to say if num is less than 0, we'll open up the brackets, and we'll say odd neg, this little up caret right here, equals, equals 1, and that is the XOR. Boom. Now, if there's an odd number of negative numbers, then we must flip the smallest absolute value to maximize the sum. Hence, we're going to subtract 2 times the min abs from the abs sum. So we come right here and we say return abs sum minus odd neg times min abs times 2. Boom, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.